Okay, let's go to Rakshan. Rakshan, are you here? You're here. I see you. Rakshan? Yes,
Yeah, I'm
please
here.
go ahead.
Just 1 second.
Yeah, please go ahead, Rakshan.
Can you see my screen?
Yes, I can see. You want to turn on your video so that we can see you?
Oh, yeah.
Okay, great. Yes, we can see you. You can go ahead and present.
Okay. Hi, my name is Rakshan, and I go to International Academy in Troy, Michigan. And my topic was about the correlation between environmental factors and Alzheimer's disease, but more specifically, how do specific environmental factors such as air pollution, water pollution, diet, or exposure to toxic metals contribute to the risk of developing Alzheimer's disease? So this topic kind of interests me because, well, Alzheimer's is idiopathic, meaning that we don't know the sole cause of the disease. We know we're like 70 or like 80% sure that it could be like a variety of things like genes, it could be affected by blood pressure, stuff like that. But as our world is advancing and like there are more humans in the world, we kind of need to like develop new technology, and that kind of results in us using like new chemicals or new materials, kind of combining like materials that have been generated in the past. But oftentimes these make like they have like side effects, or they make like byproducts, and that affects like our air, our water. Specifically, like I decided to focus on toxic metals and how they can, and like pesticides and how they can put chemicals into our food. So Alzheimer's disease claims millions of lives annually, and current treatment options offer limited success in slowing its progressions. So traditional approaches focus on like managing symptoms, but I think we need more research so we can mitigate and prevent like Alzheimer's from affecting like this many people. And also understanding how air and water pollution and metals influence brain health, we can develop preventative strategies. So my objectives for the research were to find out what factors. So I kind of focused on pinpointing which environmental factors have strongest links to Alzheimer's disease. Like I said before, these were mainly like pesticides, or they were like toxic metals, or also byproducts that were put into like the water, or like put into the air. And to also investigate specific exposures like air pollutants, dietary patterns. Dietary patterns was also a big one. And like I said before, exposure to chemicals. And the second objective was to elucidate the mechanisms of action. So I wanted to explore like what mechanisms kind of form Alzheimer's, like inflammation, oxidative stress, the blood-brain barrier being disrupted, or or mainly the buildup of beta amyloid and tau protein, and also understanding how these mechanisms are crucial for developing targeted interventions, or once again like preventative strategies. On my literature review, I use a variety of sources, but my top three were like PubMed, NPJ, which is like a Nature publication journal, and NIH, which is the National Institute for Health. I was able to find out that metals are essential for brain function, but high levels can cause oxidative stress, disrupt mitochondria, and impair enzymes. The specific toxic metals that I found were lead, mercury, aluminum, and some pesticides that might contribute to Alzheimer's by increasing beta amyloid and tau protein phosphorylation, which leads to plaque and tangle formation. While beta amyloid aggregation is a characteristic of AD, new research suggests that it might not be the starting point. I also found that environmental pollutants can increase Alzheimer's disease and Parkinson's disease risk through oxidative stress, and reduce activities of enzymes that degrade amyloid beta can cause changes in genetic code itself. Because Alzheimer's disease and Parkinson's disease symptoms appear years or decades after exposure, assessing chronic exposures is difficult in studies. More research is needed to develop better methods for measuring past environmental exposures and identify early biomarkers for earlier diagnosis. So my methodology, I found like a trend in a lot of like the research papers that I read is a method called candidate gene approach. This is where researchers select specific genes, which are called candidates, that are already linked to a disease, and investigate how variations also called alleles, specifically like the harmful allele ApoE4. And these genes affect the risk of the disease in the presence of environmental exposures. Transgenic animals, more specifically mice, are bred to carry human risk or protective variants, like ApoE2, which is a protective variant, ApoE3, which is a neutral variant, and ApoE4, which is a harmful variant, were most used. These animals are then exposed to various environmental factors to see if these variants influence their susceptibility to environmental factors. But one limitation in this research method is that it may overlook genetic variations that only influence disease risk under specific environmental exposures. And essential metals like copper and zinc are necessary for brain health, but high levels can cause oxidative stress and disrupt neuron function. Research mostly focused on single metals, but real-world exposure often involves like chemical reactions between other metals. For instance, manganese exposure can worsen the effects of lead poisoning. And a common way to treat this is I also read this is chelation therapy, which removes excess metals from the body, but it can have side effects. And like the side effects often outweigh like the benefit chelation therapy has. It can cause allergic reactions, low BP, cardiac arrhythmia, or anemia. And researchers are also investigating targeting specific metal transporters to enhance metal removal. There's a diagram here. It's not really visible, but it's the copper transit system in brain cells. So copper binds to protein, and it like they stimulate other enzymes, and basically like they can be helpful at a certain amount, but once like there's like it reaches like a tipping point. Oh, it also reaches like a tipping point, and that could facilitate like the formation of plaques. And also, I've also found pesticide and high fat diets can trigger low grade inflammation throughout the body. And this inflammation may contribute to the formation of amyloid plaques and can impair insulin sensitivity, which increases blood sugar levels. And a result of like chronically high blood sugar is that it can damage neurons, and a high fat diet may also damage the blood-brain barrier. And some studies suggest that a high fat diet also can decrease the brain's ability to clear amyloid beta plaques. In conclusion, I've restated my research question, which is how do specific environmental factors such as air pollution, water pollution, diet, or exposure to toxic metals contribute to the risk of developing Alzheimer's disease? And the main three like things that I focused on were once again heavy metals, air and water pollution, and high fat and chemically altered diet. Um, I was basically able to find a method of research that focuses on more specific alleles and how those alleles are susceptible to like changes in the environment. But a limitation of like a single factor analysis, meaning like focusing on one metal only, is when like in real world exposures, like a lot of these metals can chemically react, and oftentimes they take a long time for like the symptoms or like the effects of those metals to like finally form. And another limitation was that I didn't have any like hands-on experience. All my research was done virtually. And since this is like a relatively new field, there's a lot of like hypothetical there's like a lot of hypothetical publications, so there's a lot of different perspectives. But finally, I would like to say thanks to Gifted Gabber and Coach Joe for giving me the opportunity to express my knowledge. And I also wanted to give a genuine thanks to Dr. Jobin for providing me with many resources and also kind of like helping me start my research project in the first place when I didn't have any ideas. I also wanted to thank Dr. Virgil for constantly helping me improve my paper and critiquing, like meticulously critiquing my paper to make it as good as possible. Thank you all for your time.
Great job, Rakshan. Yeah, wonderful topic and incredible depth. Dr. Varki?
Rakshan, good job, good presentation with the comprehensive information, like presentation that you have made. Just like a question, so do you, so we know that, like people are getting more exposed to this different metals and all. Could you comment upon like how, or do you think that there's more exposure to metals than, let's say, 50 years ago? And why do you think it's happening?
So I would definitely say there are more exposure to like metals 50 years ago, but 50 years ago there was a different set of problems. For example, like radium or like other radioactive chemicals, they were kind of used in paints or like clothing dyes. and people didn't really know that. But as like research kind of like went along, we were like able to distinguish like that these chemicals are bad. But the problems that we have now are that like um it's pretty much the same as what happened 50 years ago. Is we're not too sure what can or what can't affect our bodies negatively, and it's only a thing that comes along with research. And also it's because like the human population has skyrocketed in the last like 50 years or so. So it's like we need new chemicals or new compounds that can kind of like facilitate our lives.
Yeah, no, good job. Like, yeah, with the process of industrialization and the pollution in environment itself, like the amount of metals that people are exposed to today, it's much more than like what they were exposed 10 years ago. So congratulations, and yeah, a good job on
Thank you.
presentation.
A big round of applause to Rakshan.